we are going to see the kink method, also known as the straight deep domain method, for fold geometry extrapolation. As is indicated in the term kink method and the straight deep domain method, we are going to create straight deep domain, which is unlike the curved deep domain created during the busk method. Consider this line as the ground surface and the 2 points where lithological contact has been found out by a field geologist. Let us say this is one lithological contact and here is the other lithological contact. As you can see, both the lithological contacts dip towards some specific geographic direction, say p degree north, and this lithological contact is dipping at a lower angle than that lithological contact. We are starting with this. Later on, students can try what if both the litho contacts dip at same angle, what if this contact dips at higher angle than that. In that case, are we able to produce the kink method of fold reconstruction? Why should we apply kink method or straight deep domain method over here? Suppose during field work we are getting kink folds here or here or here. In that case, we have a confidence that this region is a large kink fold, because the small structures indicate what can be the possible large structure. There are exceptions in few cases, but generally this is true. Just to recollect, kink fold or the chevron fold are folds with straight limb and sharp hinges. So that if this is the kink fold, we can see that we are producing a deep domain over here and another deep domain over there. Say this lithology is P, here the lithology is Q and here the lithology is R, which means the PQ contact at point A has been plotted on the map and the QR contact has been plotted at point B on the map. The dip of PQ contact is less than the dip of QR contact. So, we are dealing with basically the three lithologies P, Q and R and two litho contacts. Step 1, join the AB line. Step 2, this contact is drawn skyward direction and with a faint line. Step 3, find out the angle ABM. The steps that I am telling, students need to stop the presentation once a while and keep writing. Find out the angle ABM. With the angle measurer, I find the angle to be 38 degrees. Draw the same angle on the AB line from point A. So, angle ABM equal to 38 degrees is equal to angle NAB. We have obtained a point D. Point D is the intersection between the line MB and AN. They intersect at point D. So, we can say from the triangle ADB that the AD length is equal to the DB length, because these two angles are the same. Next, from point D, I have to draw a line parallel to this lithological contact. So, I can use set squares to draw that line. The next step is find out the angle KDB, and I can do that. It is 150 degree in my drawing. Find out half the angle KDB, which is 75 degrees. Draw a line dz so that the dz line bisects angle KDB. So, I draw half the KDB angle as 75 degree. So, this is the dz line and the dz line bisects the angle KDB. Therefore, in my drawing angle BDZ is equal to angle KDZ is equal to 75 degrees. This dz line is going to be presented as the axial trace of the kink fold. Next, this dz line intersects this lithological contact at a point. This point is marked, and from that point I will draw a line parallel to DB. Say this point is small a. So, what I have to do, through small a point draw a line parallel to DB. So, I use set square once again to draw that line, and the kink fold is produced. Where is the kink fold in my diagram? KD, and this line I have highlighted with blue color, and this line and that line. So, this defines the kink fold. As I told you earlier, this line is the axial trace. What is an axial trace? It is the intersection between axial plane and another plane. Axial plane and another plane intersects, and this intersection is a line. This line is known as axial trace. What is that another plane in this case? This another plane in this case is the plane of drawing. So, this angle is equal to that angle. Where the kink method will work, where on the surface we get kink folds or chevron folds, and suppose by geophysical studies we have an idea that below the surface over here or some other geological indication we have got that there are flat ramp and flat geometry, and preferably with sharp corner, the joining place between the flat and the ramp and the flat, this is a sharp contact. So, we can expect fold geometries like this. We have already seen the fault bend fold and the fault propagation fold. In both the cases we get chevron fold or kink fold. So, if we have an idea that we are extrapolating a fault bend fold or a fault propagation fold, we will prefer to use the kink method and we may avoid the busk method. There can be a situation where a geoscientist is making a reasonable case that the contact between flat and the ramp is not sharp, rather it is smooth. In that case the busk method can be applied. And also, as I told you, not just the subsurface information, but the surface information here and here and here, what kind of folds we are getting, that also is a guiding factor. In case AB is horizontal, if AB is horizontal, then angle DZB can give us the dip of axial plane, but only if AB is horizontal. In the case of kink method and also in case of busk method, we have assumed that the lithological contacts dip towards the same geographic direction. In this particular drawing, the dip direction of axial plane here as an axial trace is 180 degree opposite to the dip direction of the lithological contacts. So, as we started, towards p degree geographic north was the lithological contact's dip direction. So, in that case the axial plane's dip direction here is p degree plus 180 degree or p degree minus 180 degree geographic north. Across the axial trace, across means in this direction and in this direction, the two different dip domains are defined. This is a dip domain where we have the constant dip of the folded layers, and here we are having constant dip. In this specific diagram, the folded unit Q has been drawn. This was the lithological unit Q. So, folded Q unit has been drawn. As per this diagram, the KD limbs dip is less than that of the BD limbs dip. This axial trace is the boundary between the two domains. We can call domain lambda and domain mu, and this line is also therefore known as the domain boundary line. This drawing has been constructed for a specific AB length and a specific angle DBA. If these two parameters are changed, sometimes the kink method may not work. I am going to pose a situation. You must try with the geometry box instruments and see where the method will fail. Take this case where the AB length, if I join by a straight line, the length is 5 centimeter, ground surface which is non-horizontal, and this angle, if I join it and extend this angle say 24 degrees and this angle say 74 degrees, lithological contacts. The lithological contact between unit P and Q has a dip of 24 degree approximately, and the dip of the contact between Q and R rocks is say 74 degrees, and AB is near horizontal line, AB line is near horizontal. I would request the students to apply kink method and they will be stuck at some point, and you understand that depending on the AB length, depending on the dip amounts, sometimes the kink method does not work.